On July 1st, 2025, a routine sky survey in Chile detected a faint object racing toward Earth at 152,000 miles per hour, the fastest velocity ever recorded for a solar system visitor. Within hours, astronomers realized this was no ordinary comet. 3I/Atlas, the third confirmed interstellar object to enter our solar system, was about to challenge everything scientists thought they knew about comets. While NASA quickly reassured the public it was natural, Harvard astrophysicist Avi Loeb began documenting 15 anomalies that defy conventional explanations. As the comet blazed past Mars, Venus, and Earth, a scientific firestorm erupted. Was this a rare natural fragment from another star, or could humanity be witnessing something far more extraordinary? The Asteroid Terrestrial Impact Last Alert System facility in Rio, or TATO, flagged an unfamiliar object moving through Virgo. Astronomer Larry Deno was reviewing detections when 3I/Atlas appeared. It looked like a completely garden-variety near-Earth object, Deno recalled. But follow-up observations revealed a hyperbolic trajectory, unbound by the sun's gravity. Pre-discovery images from May were recovered, showing the object had passed through dense galactic center star fields. By July 2nd, the International Astronomical Union confirmed it, the third interstellar visitor after Oumuamua and Borisov. Multiple observatories detected a faint Comet tail, earning it the comet designation C/2025N1. Within days, 122 observations from 31 observatories worldwide poured in. The race was on to study this visitor before it vanished into the cosmic void. Dr. Avi Loeb, Frank B. Baird Jr. Professor Harvard, noticed something extraordinary. Its retrograde trajectory is aligned to within 5 degrees with the ecliptic plane, Loeb wrote, with a likelihood of 0.2%. For an object from interstellar space, such precision was stunning. Random visitors should arrive from any direction. A retrograde orbit near the ecliptic occurs in less than 1 out of 300 interstellar paths. Oumuamua arrived at a steep angle. Borisov's trajectory was unremarkable, but 3I/Atlas threaded the needle with uncanny accuracy. Some suggested gravitational focusing could explain it. Others noted objects ejected from planetary systems might carry that geometry. But Loeb argued such a trajectory would be ideal for a probe designed to study multiple planets. If you were designing a mission to survey a solar system, he noted, you would want to pass through the plane where the planets reside. As 3I/Atlas drew closer through July and August, something unusual appeared. A jet of material streamed not away from the sun, but directly toward it. This sunward anti-tail persisted through multiple observations and couldn't be dismissed as geometry. Amateur Satoru Murata captured striking images on November 16th, using a 0.2-meter telescope, showing multiple jets both toward and away from the sun. Belgian observer Alphonse Diepvins documented similar features on November 22nd. The Virtual Telescope Project recorded a prominent anti-tail on December 30th. Multiple independent observers saw the same phenomenon. Traditional comet physics struggled to explain sustained sunward jets. Solar radiation should blow particles outward. Some proposed unusual dust dynamics or complex rotation patterns, but none fully accounted for persistence. Loeb saw a different possibility: directional thrust from a technological source making course corrections. On November 19th, NASA held a press conference. Nikki Fox, NASA's Science Mission Directorate Associate Administrator, delivered a clear message. We were quick to say, yep, it definitely behaves like a comet. We haven't seen any techno-signatures. NASA had deployed 12 space assets: Hubble, James Webb, Mars Reconnaissance Orbiter, MAVEN, Psyche, Lucy, Europa Clipper, Stereo, SOHO Punch Perseverance, and ESA's ExoMars. Images showed a typical comet with icy nucleus, gas, and dust. Spectroscopy matched known cometary compositions. Yet Loeb pointed out NASA hadn't addressed the specific anomalies. The ecliptic alignment went unmentioned. The sunward jets received no technical analysis. The foundation of science is based on humility to learn, not the arrogance of expertise, Loeb stated. His argument was straightforward. Decades studying solar system comets created a framework that might not apply to interstellar objects. That framework had never included technological artifacts. Humanity launched Voyager into interstellar space. Other civilizations, given billions of years and millions of habitable worlds, would have done the same. A Freedom of Information Act request regarding 3I/Atlas received an unusual CIA response. Rather than confirming no records existed, the CIA issued a GLOMAR response, stating they could neither confirm nor deny records pertaining to the object. This language is reserved for classified matters where acknowledging files will reveal sensitive information. Loeb seized on this in a January 2026 essay. If this was clearly natural to everyone, why would the CIA treat records dealing with a comet as classified? The simplest interpretation, Loeb suggested, was that government officials wanted to verify the object posed no threat. Even if remote, intelligence agencies learn from dismissing low-probability, high-impact events. September 11th, October 7th, the calculus had changed. The CIA's response suggested classified scrutiny had occurred. What conclusions were reached remained unknown. James Webb spectroscopy in August revealed carbon dioxide, water vapor, carbon monoxide, and water ice. The comet emitted 129 kilograms per second of CO2, 6.6 kilograms per second of water, 14 kilograms per second of CO. Everything seemed normal except one detail. Water content was only 4% by mass. Most comets exceed 50%, while some show lower water. 3I/Atlas was extreme. Loeb proposed an alternative. The plume might have resulted from sunlight releasing ices and dust accumulated on a technological object's surface during its interstellar journey. A spacecraft traveling millions of years would accumulate frozen coating. Solar heating would sublimate this layer, creating cometary appearance without revealing what's beneath. Why would an ancient interstellar comet, potentially 7 billion years old, retain enough volatiles for visible outgassing? Most comets become inert after repeated stellar passes. 3I/Atlas was moving at 68 kilometers per second, 152,000 miles per hour, during October 29 perihelion. This speed, combined with estimated mass, produced unprecedented energy. The object made close planetary approaches. Mars on October 2nd at 18.6 million miles, Venus November 3rd, Earth December 19th at 167 million miles, and projected Jupiter March 16th, 2026. Each encounter offered gravitational perturbations, yet preliminary calculations suggested minimal deviation. The combination of high speed and precise encounters was statistically unlikely for random trajectory. Loeb calculated the probability of the forecasted Jupiter distance matching Jupiter's hill radius, where objects can be captured with minimal fuel, was 0.00004 or 1 in 25,000. Lagrange points at hill radius are ideal for stationing spacecraft. A civilization observing a planetary system might naturally choose such positions. Polarimetric observations from Very Large Telescope, Nordic Optical Telescope, and Rosen Observatory between July and August revealed extreme negative polarization at small phase angles, unprecedented among known comets, including 2I/Borisov. The polarization suggested unique mixtures of icy and dark material in an unclear configuration. Typical comets show modest negative polarization, transitioning to positive at larger angles. 3I/Atlas was orders of magnitude more extreme. Trans-Neptunian objects sometimes display similar signatures, but 3I/Atlas exceeded them all. One explanation involved highly reflective ice crystals mixed with organic compounds from billions of years of cosmic ray processing. Another tied polarization to unusual anti-tail jets. If material expelled in non-standard directions by mechanisms other than sublimation, resulting particle distributions might produce anomalous polarization. Loeb noted certain technological surfaces designed for solar collection or thermal management could also generate extreme polarization under specific illumination. Others proposed exotic mechanisms involving subsurface pressure. Loeb saw evidence the acceleration wasn't purely from outgassing. If a technological system provided additional thrust, it would explain why visible activity seemed insufficient for measured forces. Amateur astronomers worldwide captured independent data. Using backyard telescopes to private observatories, citizen scientists shared images online within hours through forums, and social media. Virtual telescope project live streamed December 19th approach, allowing anyone to watch real time. Observer networks coordinated continuous coverage across time zones, creating distributed monitoring complementing professional observations. When Murata captured multiple jets, others quickly confirmed from different locations. Amateur spectroscopists measured color and emission lines. This grassroots participation demonstrated open science power. No single institution controlled data. No embargo could suppress citizen observations. If 3I/Atlas displayed anomalous behavior, hundreds of independent observers documented it. The transparency contrasted historical cases where unusual events were observed by few professionals, leaving room for conspiracy theories. With 3I/Atlas, evidence was in people's hands. Professor Jason Wright from Penn State systematically addressed each anomaly in Loeb's 3I/Atlas Anomalies Explained. Wright argued ecliptic alignment could result from observational bias or gravitational focusing. Sunward jets were complex dust dynamics with specific particle sizes. Water pore composition fell within known range of Kuiper belt objects. Extreme polarization was consistent with organic compounds and ice grain mixtures. Point by point, Wright demonstrated each anomaly could be accommodated within existing physics if allowing natural variation and rare conditions. Professor Josh Wynn from Princeton questioned statistical methodology. None of the anomalies were predicted. Hence, I cannot take seriously the very low probabilities assigned to them. When invoke post hoc analysis problems. Without pre-registered predictions, anomalies might reflect confirmation bias rather than genuine evidence. Loeb defended his approach, noting the Jupiter flyby offered a test. If 3I/Atlas passed a predicted Hill radius with precision, it would constitute verification, strengthening the case for intentional control. By December 2025, Loeb's tally reached 15 anomalies: ecliptic alignment, Jupiter Hill radius match, sustained sunward jets, wild signal trajectory, extreme polarization, water pore composition, rapid perihelion brightening, blue color shift, mass loss paradox, precise planetary encounter timing, unusual outgassing ratios, and spectroscopic deviations. Combined probability of all occurring together by chance reached vanishingly small values. Loeb assigned 3I/Atlas a preliminary ranking of 4 on a scale from 0 natural to 10 confirmed alien threat, indicating most likely natural but warranting investigation of alternatives. Critics maintain multiplying probabilities of non-independent anomalies was statistically unjustified. Many features might share common causes. Probability assignment was subjective when the interstellar sample size was only 3. 1 in a million still allowed natural occurrence when observing thousands of objects annually. 12 NASA spacecraft observed 3I/Atlas across electromagnetic spectrum. Hubble JWST and Mars Reconnaissance Orbiter showed fuzzy comet with icy nucleus and active coma. Spectroscopy revealed gas compositions consistent with sublimating ices. Green Bank Telescope found no narrowband signals. X-ray observations detected expected fluorescence. By conventional measures, 3I/Atlas looked like a comet, yet anomalies persisted. Perhaps 3I/Atlas represented natural diversity of comets across the galaxy, a rare but entirely physical combination challenging assumptions built on limited local samples. Perhaps billions of years in interstellar medium, exposed to cosmic rays and galactic fields, modified in ways producing observed anomalies without technology. Or perhaps, as Loeb maintained, the community was witnessing the first confirmed interstellar artifact, camouflaged beneath accumulated ice, following carefully designed trajectory through a star system under long-term study. March 16th, 2026 loomed as a decisive moment. If 3I/Atlas passed Jupiter at Hill radius with predicted precision, it would challenge fundamental assumptions about celestial mechanics. The comet would force reevaluation of what interstellar objects could achieve through purely physical processes. Whether 3I/Atlas is a rare natural fragment or the product of unknown engineering, only facts, not speculation, can answer what this object truly is.